this video, we are going to discuss similarity in right triangle standard number 7, which is basically about the cofunction theorem. You will need a calculator for this video, and basically, we have two objectives. Number one, use the cofunction theorem, and number two, explain why it works. Before we launch into that, I'd like to do a quick review over what we had in class yesterday. In class yesterday, we had problems where we had them looking similar to this. We had a right triangle and a similar right triangle. And we were given the task of explaining why the sine of angle A is equal to the sine of angle C. You remember the work that we had for it was based on recognizing how you get the sine of angle A. Absolutely, Shannon. Since sine is opposite over hypotenuse, we started off by observing opposite of A over hypotenuse. And in that particular instance, where is the opposite of A? Yes, Josh. It's our opposite of A, 24, and the hypotenuse was 26. All right. Looking at the next triangle, the sine of C. The sine of C came from opposite of C over hypotenuse. And we noted 12 is the opposite of C, 13 is the hypotenuse. So we had 12 over 13. These pieces that we were doing yesterday led us to the conclusion that when we simplify both of those fractions, we can verify that they actually are the same. By itself, this work is not an explanation. This work is only a verification. And so we had an additional sentence writing up and explaining why this stuff worked. Our process today is going to be very similar to what we did yesterday. We will have work that looks very, very similar to this. And after we have the work, we will need to have a sentence writing up and explaining it. Of course, we're not doing the same thing with a different standard. Our focus is on the cofunction theorem. And in order to do the cofunction theorem, we're going to start off with just some basic numbers. For instance, I'd like you to take the calculator and just type in the sine of 40 degrees. Well, one thing worth noting for us, before you launch into anything with your calculator, I want to verify. There are two different ways of measuring angles. One method is called radians, the other is degrees. Now, so far in your entire life, you've always used the degree system of measuring angles. Later on, when we get to our circle unit, we will see where radians come from. We will work with them, but we're not there yet. The calculator is programmed to do it either way. They have a setting that lets you measure angles in either degrees or radians, and so to make sure that we're getting correct answers here, we got to make certain our calculator is in degrees. So start here and press the mode button. The mode button brings up a bunch of the different settings. When you scroll down, you'll see at this section here, they have both radians and degrees. Before we move on, make sure that your calculator is set to degrees. Yep, you would just highlight degrees, press enter. So enter, mine is currently set to degrees. If you wind up using your phone calculators, be careful because your phone calculators are also programmed for radians or degrees. You'll have to make certain that your calculator, whichever one you use, is in this correct settings. Now for this one, to get back to the home screen, we have to press second quit. Quit is located above mode, so second quit, and now we're back here.
I switch clear.
Clear is another way that you could have done it as well. Alright, so here's the next piece we said. Type in the sine of 40 degrees, and just see what we get. Sine of 40.
6.64.
0.6428. When we write these pieces out, typically we're going to go to 4, round it to 4 decimal places. Not 2, 4. We want that enhanced accuracy. Okay, type in the cosine of 58 degrees.
5.399.
Alright, so we get a value. If we wanted the tangent of 34 degrees, we can type them in and see what we get. Right? Using the calculator now, I'd like you to check on two things. Type in the sine of 40 degrees. Type in the sine or the cosine of 50 degrees. Let's compare them and see what we get. Sine of 40, cosine of 50. And we're noting we got the same thing. Why did we get the same thing? This is the cofunction theorem. Using it and explaining it is what standard number 7 is about. This is the focus we've got.
Is it because
Okay, so to use the cofunction theorem, basically it tells us we've got the sine of an angle. The cofunction theorem lets us say sine can be turned into cosine. But when we do that, it needs to be the other angle. Well, if we had a triangle drawn, a right triangle, where we had a 26-degree angle, how big is the other one?
64?
Where did the 64 come from?
180 minus 90 minus 26.
Okay, we know that the triangle overall adds up to 180. When we subtract off the 90 degrees for the right angle, we're left with 90 degrees for the combined angle 1 and angle 2. Yeah, similar to a linear pair, except a linear pair is going to be two angles that add up to 180. These are more like a complementary pair, two angles that add up to 90, forming a corner. So what we would notice then, since these two angles add up to 90, when we subtract off the 26, that's how Josh got 64. This is exactly what the cofunction theorem does. It tells us sine is the same thing as cosine as long as we use the other angle. We're done. Let's run through a bunch of quick examples. The sine of 84 degrees. Rewrite this using the cofunction theorem. What would it look like? Sine is turned into cosine. And if you've got 84 degrees, the other angle that gets you up to 90, it's 6. We're getting that just by taking and subtracting it off from 90. Whoa. Okay, let's think of some others. The sine of 42 degrees.
56, 58.
Sine will be turned into cosine,
48.
and we simply have to subtract that off of 90. 90 subtract 42 gives us 48. What about the sine of 18 degrees? sine gets turned into cosine.
32.
90 subtract 18 is 72. The cofunction theorem also works the other direction. If we start with a cosine, cosine can be turned into sine by taking the other angle. So what's the other angle that's going to take you from 20 to 70, or up to 90? Yeah, I kind of just said it there, 70. Okay, if we have cosine of 75 degrees, rewrite that using the cofunction theorem. Sine of 15 degrees. A portion of our homework is based on this skill. This is using the cofunction theorem. A more significant part, why is it true? Okay, let's consider this triangle. We'll start off with the Pythagorean triple, 5, 12, and 13. You may remember a Pythagorean triple, 3 numbers that fit the Pythagorean theorem, specifically 3 whole numbers, so no fractions, no decimals. Rounding to the nearest whole number, this piece is a 67-degree angle, and our other angle B is a 23-degree angle. Please notice what the cofunction theorem tells us. The cofunction theorem says the sine of 67 degrees is equal to the cosine of the other one. Why? Here's our task. Why is this thing true? Let's start by considering the process we used yesterday. What is the sine of 67? Not using a calculator, using this diagram. Well, how do you get the sine? Sine is opposite over hypotenuse. Cosine comes from where?
Adjacent and hypotenuse.
So we'd have the adjacent side of 23 degrees over the hypotenuse. Well, consider this. Once again, we're being asked to explain why is this thing true? What side length is opposite to 67?
23.
12.
Well, when we take across there, we get 12. It's opposite to 67 degrees. Remember, opposite, adjacent, and hypotenuse all refer to the same, they all refer to side lengths, not angles. We have to use the sides of the triangle. Okay, so there's our 12. What about adjacent? We want to have
13.
adjacent 23. Well, remember, 13, the longest side, is always the hypotenuse.
So it's 5.
When we say adjacent, we mean the adjacent leg. Which leg is adjacent to the 23-degree angle? It's right here. And so in both of these, opposite to 67 is talking about this number 12. Adjacent to 23 is also talking about this side length 12. When we look at verifying, opposite of 67 and adjacent to 23 are both referring to 12. Of course, both of them are using the hypotenuse of 13. So based on this work, we can verify that they're both 12 out of 13. But that's still not an explanation. Why are they the same?
Because, I don't know, try to cross multiply, right?
To consider this, and to simplify it a little bit further, I want to use a right triangle with a Pythagorean triple, 3, 4, 5, angle A and angle B. And I want to answer the question, why is the sine of angle A equal to the cosine of angle B? Let's run through the same process, doing the verification. Sine comes from opposite over hypotenuse. Cosine comes from adjacent over hypotenuse. We know two fractions are going to be equal if their numbers are all the same. Well, of course, hypotenuse and hypotenuse, that's not going to change at all. We're using the exact same number for both of them. Of course it's going to match. In this instance, our hypotenuse is 5, matching 5. The cofunction theorem claims we are guaranteed to wind up with the same numerator. Why? Keep this in mind. Where is the opposite of angle A?
3.
That's the 3. Also consider, where is the adjacent to angle B?
3.
You notice, just like we did in the last time, they're talking about the same side. Opposite of angle 1 and adjacent of angle 2. It's two different ways to describe the same side of the triangle. In both instances, whether it's opposite of A or it's adjacent of B, both instances are giving us the same side because they're talking about the same side. This is why the cofunction theorem works. We have two different names for the same side. It's similar to saying Mr. Gartner and the Newtown High School principal. It's two different names for the same person. That's what's going on here. Opposite of A, adjacent to B, two different names for the same side length, in this picture, 3. That's what we need to write up. And so we can write up a sentence or write up an explanation saying sine of A will equal the cosine of B because opposite of A and adjacent of B are both the same side of the triangle. We could also write it up, opposite of A is the same side of the triangle as adjacent of B. Basically, we're just writing up a sentence that's saying it's the same piece. So, when we take sine of A, using our work, we know sine of A is the opposite of A over the hypotenuse. But since the opposite of A is the same thing as adjacent of B, that substitution tells us this is still the same. And that's exactly what cosine of B is. The stuff we have in the red, here's our explanation. Why Why does it work? Because we're talking about the same side length in two different ways. That's it. Let's look at one more example. Okay, so let's consider this example then.
Which number do we choose?
A, B, C, 85, 150, 172.4, and we would like to explain why does the sine of angle C equal the cosine of angle A. Okay. Notice that. Remember where sine comes from? Sine comes from the opposite of angle C over hypotenuse. Cosine comes from the adjacent of A over the hypotenuse. We are going to make this observation. Opposite of C is the same side of the triangle as adjacent of A. Noting opposite of C is that 150. Adjacent to A is also that 150. They're both talking about this right leg in this picture. Because they're talking about the same leg, we could put it together and say in the sine of angle C is opposite over hypotenuse. But that numerator, the numerator, opposite of C, we've said is the exact same thing as adjacent to angle A. So this doesn't change it. But since adjacent of A over hypotenuse is cosine, we have our written explanation.
So we write, notice that opposite C, we write that one. So we just basically have your sign.
And thus we're done. Based on the comments you guys just told me, you're absolutely correct. All we're doing is explaining why these things are the same. And it's because we're using two different names for the same side length. That's all the cofunction theorem is. Understanding that sine of angle 1 will equal cosine of angle 2 because it's the same fraction, no matter what the triangle is. Big right triangle, small right triangle, it doesn't matter. It will always wind up having this relationship because it's always talking about the same side. And that's really it for this entirety of standard number 7. Standard number 7, using the cofunction theorem. Using it is no more complicated than saying the cosine of 19 degrees and change it. That was the sine of 90 subtract 19 is 71. That's using the cofunction theorem. And our second objective, explaining why it works, it's just this. This is our explanation. Understanding its two names for the same side. And we're done.